So in this video, I want to go in detail about how to deal with NBT data and predicates in integrated dynamics. The reason why I make this video honestly is because I've realized that after not using integrated dynamics for like 2.5 to 3 years, that I have unlearned how to do the more sophisticated stuff in it. So to some degree, this video serves as a way of like me documenting my own findings and reinforcing my own learnings, but also because I realized that upon like trying to look up again how the sophisticated stuff is done, that almost all the knowledge is like all over the place and needs to be sorted together. And I'm trying to create basically a one-stop go for me to come back to whenever I'm trying to touch this mod again. But at the same time, I'm feeling free to invite anyone to use this video if they are trying to get into integrated dynamics and have been struggling to understand the resources on the Discord server or on other YouTube videos. The reason why I'm in this situation is mostly because I try to avoid integrated dynamics where possible, because where it is a very powerful mod, it can also be a little bit daunting and also has an almost infamous reputation for having issues when you let it grow out of proportion, as in you should never try to automate anything auto-crafting wise with variable cards, or you're probably going to kill your server. And then there's generally the reputation that this mod has the circumstance of causing very, very, very rare crashes that can be very bad to servers. So when you use this mod, I would strongly suggest that you have some type of short-term and long-term backup policy, as well as if you have a situation where you can get around solving it without integrated dynamics, that you should also look into other options. There are other very quick and very powerful options available. There's the Super Factory Manager, there's XNet, there is, depending on what is in your modpack, right? There's A2, Applied Energistics. So when does that situation come where you need integrated dynamics? For me, the moment where I start using integrated dynamics for something is when I have to respond to NBT data. And I'm not just talking about filtering NBT data, because there's plenty of options to do that already. When I'm talking about interacting NBT data, is like actually reading the NBT of a block and doing very specific operations and comparisons with it that aren't as simple as, oh, does this have the same NBT as another item? I figured in order to make sense out of this that I would come up with a sophisticated example for this. So yeah, this is going to be a very long video, but the idea of like, I want to give people like this single one go trip, single stop, so I apologize, but that for that reason the video will be relatively long. So what is the example that I came up with? We are talking about Astral Sorcery. Eventually, when you do Astral Sorcery, you will get into the situation where you will want to farm so-called celestial crystals. So those celestial crystals have 3 properties in them: the size, the purity, and the cutting. And you want to have the min-max before then doing additional processing with it, like attuning them to certain star constellations and such. Now, maxing the purity stat is not really difficult, because eventually how you start getting new crystals is that when you dump them into liquid starlight, they will keep growing, and when they grow past a certain size, they will split into 2. And the split of celestial crystal always has a higher purity or the same purity as the previous one. So like by just letting this one forever, you will get to 100 purity eventually, and it is relatively easy to do. So where things are getting interesting then is, it just happened. There was just a split, so a new crystal got born. So purity is relatively easy, but now where things get interesting is size and cutting. Now, the way how this here works, and this is why it works with integrated dynamics, is that I've already thrown an attuned celestial crystal in it, which in comparison to the other celestial crystals is considered a different type of item. Yet you can also grow attuned celestial crystals, and when they split into an attuned celestial crystal and celestial crystal. And that's pretty interesting because all I really have to do is then just see if there's 2 items nearby or more than one. And if so, I'm trying to collect Celestial Crystal, which, because Celestial Crystal is a different item than the attuned Celestial Crystal, only causes me to pick up 1 item. So far, so simple. So I am able to make an infinite amount of Celestial Crystals, and it doesn't even require me integrated dynamics. But now comes the part where I have to farm the size and the cutting. More importantly, I want to be able to farm the size, and after I'm done with max size, I want to pick them up. That doesn't work with this setup, because the way how the setup works is I wait for the split and I detect the split and pick them up, but the moment it splits, the size of both crystals decreases. So for me to like being able to do that, I would require to detect if the Celestial Crystal has hit a certain size, like max size for example. But since the cutting stat can be randomized, that isn't as simple as just putting an max size, max purity, max cutting crystal into an NBT filter and see if the NBT filter matches. So this is a very good use case. So the idea of like, I want to grow these crystals to max size and then before they split, pull them out of the liquid. That's a really good use case for integrated dynamics. I could immediately jump to predicates now, but the thing with predicates is that if you've never done stuff with integrated dynamics or programming for, that you will absolutely not understand anything I'm doing. So the first thing I'm gonna do is to actually go ahead and start by doing a very primitive example that has a very obvious flaw and is way too manual and not really scalable. But for the sake of like explaining how the logic behind this entire process works, so that we can then proceed to see, okay, how do we fix this? And then we basically start very primitive in working our way to why we have to use predicates and how they function. So let's do a very primitive example. We have this crystal. We want to throw this crystal inside here. There's going to be an infinite amount of liquid starlight being farmed here. This is already set up using a scripted factory manager. Honestly, I don't know why this one doesn't have one in it. I must have probably forgotten it with the label gun. Anyways, doesn't really matter for this example. We have an infinite amount of liquid starlight in here, and we can throw the crystal inside. And we want to take the crystal out when the size is greater than 800. Why do I use greater than and not equals 900? That's so that we will run into a very specific problem later that I figured was important to include in this video, so that when you guys run into this, or when I run into this again watching this in 2 or 3 years from now, that I know how to take care of it. So we will do greater than simply to add an additional layer of difficulty so that we run into issues and learn how to deal with them. Okay, so for this crystal, we want to check if the size is above a certain value. And we're going to start very, very simply by just dealing with this crystal. We're not going to do any abstraction. We're not going to do any alternative declaration. All we're going to do is like, we go to our logic programmer, and in that logic programmer, we have the ability to do define lots of operators, different relationships, variables. This entire list is extremely daunting. And I'm gonna be real with you, I never used like probably 99% of the things that are in here. And that's totally fine. That's how programming works. No one that knows how to program or develop something knows 100% of programming language. It's for a reason why they say that the art of programming is not about knowing shit, but knowing where to look it up, or like the art of Googling basically. And to some degree, most things that are listed in here are like very common primitives that you would expect in every programming language, or like each logical language. And you not really are expected to scroll through this list or expect to know what most of this are, but rather having an idea of what you want, use the search bar and see if there's anything in here that matches your needs. In this situation, we have an item and we want this item to one way or another be represented in the integrated dynamics system. So what that means is we need to do something with item. So that already reduces the list quite a lot, but the thing that we actually need is the capital I item at the very top already. And what this basically does is just it allows us to give him an item, and it gives us a variable that represents this particular item. So now we have this variable. If we have the labeler gun in our inventory, we can press E to give this thing a name. And I would suggest starting with a naming convention very early, so that once you get a lot of variable cards, that you have an idea of what you're even doing, especially when you, like, in a month from now, still look at your system, right? So have the celestial crystal. I did pull it in here, and it gave me this item variable card. So this variable card now represents this particular item. It doesn't represent celestial crystal as an item type. It is really this particular instance of a crystal. So when I take this crystal, the variable card does not represent this crystal. It represents this singular instance, this unique celestial crystal. This will have certain problems, but we do this for simplicity's sake, that we say, okay, let there be a crystal, and we're gonna make an item card of it. Now we wanna see its size, and this size is so-called NBT data. So what we have to do is we have to get the NBT data of this item. So what we basically can do is we type item, we type NBT, because that's the situation that we have. We want to do something with an item, and we want its NBT. We type in both, and it gives us a list of all things that have something to do with items with NBTs. So there's, for example, the option to say we can take two items and compare if the NBT is equal, which will basically mean that the items are, like, completely identical. Like, if I were to, like, you know, make a copy like this, that would work. But there's also this thing here. And this thing here is an item NBT brackets. We see its category item. It accepts an item and it gives us NBT back. This is what we're looking for, but in case that we wouldn't know, we can press shift and it gives us an explanation of what it was. And it tells us, yeah, okay, we're gonna get the NBT tag of a given item. So when we press on this and hover over it, it will tell us, yeah, I want an item, and in return, I'm gonna give you the NBT of that item. So what we expected to do here is we have this variable that is an item, and this is what we have to pull in here. We cannot pull the crystal in here. We have to pull the variable card representing the crystal in this. Now we have the ability to pull a variable card in here. We get the checkbox. That means we did everything right. And we can give that thing a name. And I'm gonna call it NBT root. Because what this essentially is we have now the NBT data that belongs to this item. So we have many ways to look into this now. If you're in vanilla, the only option that you have, or like the probably easiest option that you have, is using the display panel, where like you install a display panel onto a network, and then you insert the NBT. Now you probably gonna get an error message because it says, oh boy, so listen, I see that you want me to read this, but this depends on the variable 0, which is this card. Basically what he says is like, I want to read the NBT data that belongs to this item crystal, which represents this crystal. But I don't know where it is. It's not in the network. This is where the variable store comes in. The variable store contains all the variables that we need for our logic to work. What that basically means is like, we want to display the NBT on this display, but as we can see on the variable IDs field, it depends on item crystal to be available. So we throw this in here, and now it can suddenly print it out. And now we have the ability to actually read this. The thing is that there's a lot going on in this NBT tag. We can luckily see it in our tooltip in case we wouldn't have like Voila or the one prop installed. There's the option to press copy on clipboard, and then you paste it into some notepad or something like that. And that way you could relatively easily inspect what's going on inside. If you have integrated NBT installed, which is like an add-on or like an additional mod, you have access to the NBT extractor. And that thing makes your life a lot easier, as in you can take the NBT, put it in here, and it gives you like an easily interactable GUI where everything is listed. We're gonna see this thing later once again, because there's even more stuff you can do. But for now, I'm gonna show the solution for the rare circumstance that you're using a modpack or an installation where only integrated dynamics is installed, but not integrated NBT. Because now the situation is, okay, we have our NBT here, but there's a lot of junk that we do not care about. We do not care about the purity. We also do not need the collective capability, which is the card value. When you look at it, card value is 67. We also do not care about the fracture, which is a stat that is like not really relevant until like much later when you do double attunements and crystals have a chance to break. And I have honestly not even an idea what size override is for. So like, we honestly only want size. And if we do not have the NBT extractor available, what that means is we have to really now tell him that instead of wanting the root, we want astral sorcery, crystal properties, and then size. And that is involving a lot of variables. So let's get started. I'm gonna take out the item crystal again for now. And there's my NBT root. So what we have to do now is we now know what the NBT structure looked like. Eventually we copied it in a notepad, send it ourselves in Discord, something like that. Now we have to actually traverse the path to where we want to go. So I'm gonna remember. We have to go inside Astral Sorcery. Then we have to go inside Crystal Properties. And then we want the value that isn't size. So let's keep that in mind, or let's keep notes of that. How are we gonna do that? Now we're gonna need strings. So what are strings? Strings are representations of any characters in a row. Like we have items in NBT so far explained so far, but strings can be basically anything, any sign, and that in a long row. It is typically used for text, because if we would only have numbers, there are better options. And strings have like certain limitations, as in you cannot add strings together. Like A plus A doesn't make any sense mathematically. So when you use strings to even save a number, you're not expected to add them up, because in that context, it's a word or a text. But in that context, we need strings because we wanna tell the system that certain words do exist. What are the words that we're talking about? Well, the words that we have to traverse in the NBT path. So the first NBT path that we had to go in is Astral Sorcery, is the first tag. So we start defining a string, and we have to ensure that it's case sensitive, so all written small or small in that context, Astral Sorcery. We want to create a string, and I'm gonna call it string Astral Sorcery in that context. That's what the str is for. Like generally I have this idea of like I'm typing the output type always at the end, and then the rest is to explain what it does. The names you can freely choose, just choose whatever works for you the best, but that's how I typically do it. We need a string Astral Sorcery, but that's not the only thing. After we are inside Astral Sorcery, we have to go into Crystal Properties. Crystal Properties. So that's what we're gonna use another string for. Then we need to go get the size value. So we're gonna define a string size. That is the key that we are looking for. Oops. Yeah, if we do a mistake, just put the card back in. Do not necessarily use a new card. We want to be like not wasting our variable IDs too much. But there we go. We have now 3 strings that contain the values Astral Sorcery, Crystal Properties with a big P, and size. And now what we have to do is basically tell him from this NBT root, we want to get the data that belongs to the strings. Basically, what we're looking for is, when we call it folders in that context, that's what NBT calls tags. So when I go type in tag. There's already like NBT tag. We do not really have anything to do with lists. There's also not the with tag option. What we're looking for is this here, and we can always just look at like, okay, what do we insert? What do we output? Does it make any sense in the situation that we're in? And if not, then we press shift and see what the comment does say about what this thing does. So in this situation here, we have, for example, the NBT value in the given NBT tag with the given key. What basically means we give him NBT, we give him a string, and it gives us whatever belongs to that string inside the NBT that we gave him back as an NBT. So we pass on that, it wants an NBT, we have only the NBT root. And the first thing we want to get into is string Astra sorcery. So yeah, that's what we're gonna do. So we put that in here and we get NBT back. So I'm gonna call it like NBT Astral. When I now go in here and say, okay, let there be an item, I want to have its NBT, then I need the string Astra sorcery, and then I basically say, look for that string Astra sorcery in that NBT. We are now in a new root that belongs to Astra sorcery. The Astra sorcery folder is gone because we have so advanced one folder or one tag in the NBT structure. And we basically repeat this one more time now so that crystal properties becomes the root. So back out with you. We repeat this process now by saying we need an NBT tag. There's our NBT tag. And instead of giving it the NBT root now, we are now giving him the NBT Astral, and we want to get into crystal properties. I'm gonna actually reorder things a little bit here. And order doesn't matter, it's just I like to keep things ordered in a way it makes sense. So now we are inside NBT Astral Crystal Properties. You can also use shorter names, but typically more information also helps you to keep things figured out. So when we now go like item crystal NBT root, we want to get into the Astral and we want to get into the crystal properties and put this into the inspector. We are seeing like, okay, we are now inside the crystal properties, and now we have more or less direct access to the size key. So now we only have to do one more step to actually get the size. And that is getting the key, which is not as trivial as in like, we can get a list of keys available, but we already know that. We want to turn that key into returning an integer. Integer in that context is a number that doesn't have any like floating points to it, like 6 would be an integer, 69 would be an integer. We could not use an integer to store 2.34. But certain operations may be limited only to certain types, so we cannot just use floats on everything, even if technically 3.00 would also be a float and is a number that doesn't really have any decimals coming after. So in that context, we're just saying for an NBT, I want to give you a string and you give me whatever number belongs to that string, which in that case is our size key. So we go into NBT Astral Properties, our size key, we make a new variable card, and that's our integer that stores the size of the crystal. So, and when we now insert all of this into variable store and throw in the insize, we see that the size is 51 and the size of the crystal is 51. So we have now learned how we can, from a given item, traverse the path to get to the size. This is the vanilla method. There's an easier method to this that is available only if you have integrated NBT. I will get to that in a moment. For now, let's finish the current step. We want to actually do something with the size. We want to see if it's greater than 800. So how do we do that? Well, at first, the system needs to know that the number 800 exists. We go to integer, once again as a number, and tell them, okay, let there be a number. Let there be 800. And I'm gonna call it int 800 because, well, that's literally what the thing does. It's an integer and it stores the value 800 at all times. That seems a little bit unnecessary until we get to the last step, which is now we do the greater. We see there's a greater than and there's a greater than or equal. I guess for this particular situation, it doesn't really matter which one we use. I'm gonna stick to greater this time. And we basically see like it accepts two numbers and gives us a Boolean back. The two numbers probably make sense as in like there's a number 1 that we use and a number 2 that we use, and it shows if the first number is bigger than the second one. What is a Boolean? A Boolean is basically a statement about whenever something is true or not. That's why the Boolean can only have two states, true or false. In this particular situation, the Boolean is true if the first number is bigger than the other, which makes sense because the statement is true. If I were to say 800 is bigger than 500, that's true. If I say that 500 is bigger than 800, that's false. And that's essentially the information that the Boolean gives us. So back to that. We basically want to see whenever the size that we extract all the way through this path is bigger than int 800. And that's our comparison. And I'm gonna call it bool result because it's a Boolean, and the result, it's basically the final step. And there's our Boolean. So when we now throw all of this into our system and take the bool result, we're gonna get as a result that it's a Boolean, so we have to insert it in the importer in the Boolean field. I'm gonna go over the importer in that context really quick. There's several blocks that behave very similarly, but I'm gonna explain it in the case of the importer now, and then the other blocks may become more trivial, as in like there's several things we can do to tell the importer what to import and how to import it. Most importantly is the background color tells us what we have to insert, but we can also hover over the items. So like this field expects a Boolean, this an integer, this an item, this a list. And then basically it's just to look at the description. So this is a Boolean that tells the importer whenever to import all items or not. When it's true, it tries to import all items. If it's false, it does not import anything. We can also provide a number which tells them how many things to import in each cycle, which we can configure here at the corner. Currently it's set to 10 ticks per operation, or which basically means twice a second it tries to import something. We can also say it only should import a certain item, or an item out of a certain list if there's multiple ones. There's the predicate, which we will get to at the end, but like there's a lot of ways how you can do it. You can also extract from like an entity, like when I have it in my inventory and stand next to the world item importer, that's where the entity fields come in. It works more or less the same for that in each of the things that you can connect via integrated dynamics. The fields may be called differently depending on what you try to do. Like in block reader may obviously have the option for you to see and interact with a block, which makes sense. So there will be differences. This is a world item importer, it interacts with entities, so there's a lot of entity stuff here. So what we just made is Boolean that will be false when the crystal is big enough, and true will be false when the crystal is too small, and true when the crystal is big enough. And as we can see, it says false because it is not big enough. So when I throw it in, it will not be imported. I hope so far that makes sense, as in like we have this crystal, and we basically told them, okay, this crystal, let it be in the system. We want to get its NBT. We want to get into the Astro Sorcery tag. Then we want to get into the Crystal Properties tag. Then we want to get into the size tag. We want to get the size as a value. And then we want to see if it's greater than 800, which is what the final step here at the world item importer does here. Greater than in size and 800. So in size must be greater than 800. This should be a very simple example for now. But I'm gonna be real with you guys. That's a lot of effort. And there's a very obvious issue with this system. This entire system builds on the fact that this item crystal is hard-coded. Like, this does not mean any celestial crystal, it means this particular celestial crystal. It works because if we throw in this celestial crystal, that's the situation that we have hard-coded our system in. But let's say we take another celestial crystal, like this one has a size of 900. This is obviously bigger than 800. If we throw this in, it's not gonna get imported. And the reason for that is because, well, it does not actually check what we throw in here. It has hard-coded to learn to always respond false based on this crystal. And even if we like where to edit this crystal here and make it bigger, that doesn't matter, because this here is like a copy of the crystal that we have made. So when we modify this crystal, then this is still 51. So let's actually throw this crystal in here and wait for it to grow. Yeah, actually, when I remember how long this can take, we should probably not do that. But you guys get the idea. If I increase the size of that, the size of this item crystal doesn't increase, and it would still say 51. So even when we let this crystal grow, this is not going to work, and it doesn't work with other crystals either, because we have hard-coded it for this crystal. So why did we do all of this? Because we have understood now how we have to solve the problem. There's just one thing we have to do different. We have to actually ensure that integrated dynamics can dynamically work with the crystal that is inside the pool. So the next step is going to be now, how do we get integrated dynamics to see what crystal is inside the pool and then execute all of those steps without us having to manually rewrite variable cards the entire time. So this is not really automated, because like we cannot keep rewriting those cards. I would probably go insane after like the second or third crystal. There's got to be a better solution. But for now, let's simplify our system by talking about the integrated NBT shortcut that we can take. So we're gonna keep item crystal for now. We have our NBT root, but we can save ourselves doing all of this if we have integrated NBT installed. Because what we can do now is, when we go into the NBT root, we can also just say, yo, I want to have the size. Here's my variable card. And now there's a new variable card that is not natively available in the integrated dynamics mod, but that is added by integrated NBT, that basically contains the information, yo, from variable number 1, which is the NBT root, please go extract root Astra sorcery crystal property size and give me back whatever is inside of it. We should probably actually property rename this variable now, because it is no longer a string. What we have actually here is something that returns the integer size. And that's pretty cool, because now what we can do is, we have the integer size already. We have the integer 800 here. So when we now take our bool result and redo it by saying greater, and saying I want to use int size and int 800, and rewrite bool result, we can now run this entire system with a lot less variables. It returns false because the size is less than 51, and all we really needed is something that represents the item, the NBT root that we extract out of it, then we have the path and it returns the size, then the 800, and then we compare the two. So we have saved 5 variables. But like I said, this only really works when you have the integrated NBT mod installed. That's why I wanted to show the other option first. Even if realistically, if you have integrated NBT, you should always use the NBT extractor option. So, this out of the way. Actually, one more thing before we get to the next thing. There's something I should talk about when you are on the Discord server. When you go to the Discord server of Integrated Dynamics to get assistance, you will most likely stumble over things like this. And you're probably wondering, what the hell am I looking at? Inside the Integrated Dynamics community, it has become very common for people to write out what they're doing in what is an Haskell-like syntax. I don't believe that this is like actual Haskell code, other than just using its syntax highlighting so that it's a little bit easier on the eyes. But technically, what they are writing about there in this code blocks on the Discord server is like basically cooking recipes on what you have to do, and it is not anything too special other than what we have just done. So when we take this example, we will quickly realize, wait a moment, all of this looks a little bit familiar. So let there be an item, that is our item crystal. From that, then we want to make an NBT root. It has to turn an item into NBT. We have to use NBT brackets and have to insert item crystal. That's what the NBT root does here. When we use the NBT extractor, we can then use create an int size that takes NBT and turns it into any. And we use the NBT extractor for that. We insert NBT root, and we go down root Astra sorcery crystal property size. This is exactly what its size here does. We have a constant number 800, which is an integer 800. So like after what you have seen in game now, this should probably make a lot more sense now, as in like it is basically a cooking recipe of like what exactly you have to do to build something. And it's also typically what people will be asking you for when like you have some very specific issue with your system and you want troubleshooting. You will be expected to write something like this. I will, following forward, bring additional examples for like the next things we will do. And so that you can copy them, but also to give you an idea of what it looks like. The syntax is not like one-to-one accurate, as in like there's no like officially agreed syntax on it. Roughly looks like this, but everyone has like their own personal flavor of like how I'm defining here that you should use an NBT extractor. Is typically not done by others that way, but it's roughly what you should expect. So I wanted to get that out of the way before we now get back to the issue. So where did we stop? We need to have a way for the system to dynamically respond to the crystal that's dropped inside the liquid. Now, the easiest way of doing that would be to read the NBT of an item that is located there. Now, this thing can't really do that. All that the world item importer can do is, well, it picks up items, right? So what we're gonna need is something that can read what we throw there. And we happen to have blocks called readers. Items are considered entities. So what we want to work with is an entity reader. We're gonna install an entity reader here now. And what it basically does is it gives us different options on how we want to treat entities that are placed in this block. As per usual, most of those are not really relevant for us. We can, for example, detect what for a rotation item frame has. There is no item frame. So that information is entirely irrelevant for us. We also do not have any plans of standing ourselves in that pool. So the players one is also relevant. We also not plan to have a list of entities in there. There's only gonna be one crystal at a time growing in this. That only really leaves this option here. And it gives us an entity type object for the entity that is inside the target space. So the interesting thing about this is that we do not have to have the entity already thrown in here for us to go ahead and get the aspect. So I'm gonna take all of the variables out and I'm gonna go in here and take something that's called the entity aspect. So when I insert a variable card in here now, this is my entity aspect. What that does mean is that this is no longer hard-coded, but rather that this variable card represents whatever entity this reader detects in this field. So when I go ahead and rename this thing, because we should rename it now so that it makes more sense. It's an entity aspect, so we should call it an entity aspect and throw it in here. Actually, different idea. Let's throw it into the display. There's not going to be a lot going on because currently there's not an entity in the pool. When I throw in a logic cable, that's a logic cable because that's the entity that we threw in here. If I throw in celestial crystal, it's a celestial crystal because that's the entity that we threw in here. And in a similar fashion, a player can also be an entity. Now, I can't really look at the display anymore, but you get the idea. So we have the ability to now dynamically respond to the entity that we put in here. However, an entity can mean a lot. It doesn't have to be an item. So in order to actually work with this thing properly, we have to tell him that instead of wanting to work with an entity here, we want to work with an item. So we look for entity item. We're gonna get a lowercase item function that is giving us the ability to extract an item out of an item entity by giving it an entity, and it gives us an item back. So it wants us to insert an entity that contains an item. We know that this is going to be the case when we throw an item in here. Now we're gonna need some variable card to store it. Let's get rid of this one. All of those we won't really need anymore for now. And that's gonna be our item crystal from the previous example. So we have now a representation of an item like we had in the first example, but instead of having it hard-coded to a crystal like before, it is now linked to the entity aspect of that reader. So what that means is that this item crystal dynamically changes based on the item entity that we throw into the pool. Now, you're probably thinking like, wait a moment, we already were at the point of having an item object before, and we already knew the solution for this. Can we not like copy the entire solution of the previous step and apply it on top of this? Now, except that instead of having a hard-coded item, we have an item that dynamically changes for the entity aspect. And if you thought that, then I have great news for you. This is exactly what we're supposed to do. So we start by getting a new NBT root where we go like, okay, so listen, I need an item NBT. This is my item. That is supposed to be my NBT root. So far so good. We have the entity aspect. We have an item crystal that is linked to that entity aspect. And now from that item we get the NBT root. Why did I redo this entire example anyways? Is because now we get into an interesting situation where like if you were to want to use the NBT extractor, we have to get a little bit more creative or like a bit tricky. We tell them, okay, let there be an entity aspect, let there be an item. We put the NBT root in here. It is currently empty. When we now throw the crystal inside, suddenly there's data. It actually works. Now that the item is inserted, we can create the extraction path. So let's look for, let's use this one. I want to get the size. So we can do that. Now I can take all of this out again. And I'm gonna take the crystal out before it transforms or something. Gonna use the label gun so that we can rename the thing to what it is, and it is our integer size. Now we need a new constant 800. Let's use u for that, int 800. Technically, you can recycle previous ones, but when I have the opportunity, I also try to keep the variable IDs in order. But technically, I could have also just reused this one if you're honest about that. But we're gonna need those later again. And now the last step, yeah, we're gonna do the greater one again. So let's do the greater one and be like, okay, in size, int 800. Where's the 5? There's the 5. Is bigger, or well, bool result. Let's be consistent here, so that it's consistent with the first example. Let's insert all of this, and let's insert the bool result. False, right? That kind of makes sense because, well, there's no crystal in here, and when there's no crystal in here, there can also not be a size that is bigger than 800. But technically, we have now dynamically responding entity aspect based on this entity reader. We extract an item out of it, it's NBT, then the size, and then we see if it's bigger than 800 using this greater than. So does it work? Let's throw this crystal inside. Well, that's not greater than 800, so that already works. But now let's try it with a different crystal. Let's try this crystal. And by the click of the noise, you have seen it got imported. What is important to know about when moving things through integrated dynamics is that you always want to have one interface side and one like controlling side. As in like right now I have like an importer that has the logic, and it will push into an interface that is connected to a storage cabinet here. The opposite example is that you use an interface on that side, and then you use an exporter on that side. You should not use an importer and exporter at the same time. That doesn't work. I'm not sure why. You could like think like, okay, when I hard code a 2 on this side, this should work because then this is 2, this is 2, it should move through. It doesn't work. Or like it may require more configuration. You're gonna make your life easier if you just use an interface. The interface doesn't really do a lot other than like that you can configure a channel, you can give it a tick rate, you can set priority, but like the controlling end, if you have only one controlling end and one interface, the controlling end will push it through the interface when it has the opportunity. But yeah, we have gained the ability to now only send finished grown crystals in here. So now this system actually works as in like I can use the liquid starlight to let the crystal grow, and once it finished growing, integrated dynamics pulls it out. And you know what? For most people, that's probably sufficient. This system can break, however, and when it does, things can get a little bit ugly. Let's say I throw in a diamond pickaxe. As we already discussed, that's not getting picked up. That's good, right? But now let's throw in the celestial crystal afterwards. Why is it not picked up? Now the thing is, the aspect that we got out of the reader only sees the diamond pickaxe, or rather we told him to only see the entity, the first entity that enters the reader. We can technically say like, okay, I want to get like the next entity by giving the integer 1, and that way we get like the crystal and such. But what it basically means is like that this system isn't entirely fail-safe. Because like when I now drop something false in here, this pollutes, the crystal can despawn, stuff like that, unexpected behavior. Could also happen with like, you know, let's have a small crystal inside, let's have a big crystal inside. Now the small crystal is no longer growing, but the big crystal is not being moved out either. Granted, this assumes that you're like making a mistake, like, I don't know, you're building your base, you're building a ceiling, you're breaking blocks, cobblestone falls into this and pollutes the entire thing. But it's not fail-safe, because what the issue is like that the decision whenever we want to pick up everything or not is still global and tied to the first item that detects the entity reader. If you like say, okay, I'm gonna like shelter this thing and I'm gonna like put a basket around it so like that no one ever gets inside, like no Enderman teleports into it, no cobblestone falls into it. This can be sufficient. But if you want to make it fail-safe, like idiot-proof, that's where the predicate comes in. But for now, let's look at our current solution in the Haskell code. So as for like the other one, I prepared an Haskell code. It is not too different to the previous one we have seen, which once again highlights this example of like we can use what we have learned in the first example to understand how the second example works. When we look at our enhanced solution, this is essentially the last 4 steps are completely the same. All we really did is like we have changed the way how we get the item crystal by using an entity aspect from entity reader that reads the first entity that enters it, which changed our solution from a statical solution to a dynamic solution. The issue is just the dynamic solution that we show is really easy to do, but it's not very fail-safe because we're making assumptions about the entity that enters, and if we import or export, it applies to all items. Like the boolean that we inserted here picks up all item entities. So if I were to like do something sneaky like this, oh, actually it didn't work this time. Let's see if I was too slow. Where's my, there. I might be too slow. But in this particular situation, it should also be possible that the diamond pickaxe gets picked up. How do we fix this? Step 3, predicate. What is a predicate? So far we have hard-coded the behavior that we have used. In the first example, we had hard-coded the input, and we have hard-coded the behavior. Hard-coded means as in like the behavior never changes. In the second example, we have made ensure that the input is dynamic, but the behavior is like still hard-coded in relation to the input. And so is the output. Now, we can do something different, and that's called a predicate. A predicate in that particular example means for each item that it tries to import, it looks if a condition is met. So far, we have like outsource the entire condition making process, and if it was true, we import all items. And we can only ensure that for the first item that enters the scanner because, well, that's what we made the process for. But we can also tell the world item importer to check for every single item if a condition is met, and if it's met, to import it. In that regards, what that means is essentially inside the world item importer, there is an entity reader built in. I lied. It is a half-truth. It is not exactly like as if we can use this thing to read something and then work with it, but we can essentially like work with it and make decisions based on it. So for the solution that I'm now introducing, we don't even need the entity reader. We can get rid of it. We can solve it only using the world item importer and make it better than the previous solution. All we have to do is we have to run it for every single thing, and we have to make the operator generic, or like as in like that we run it on each item and like generally express it without like at first defining that there's an item that we make steps upon. Like so far, the way how we worked is that we said there's an item, do thing number 1, do thing number 2, do thing number 3. And like what's basically an order of operations. What we now gonna do is very different to the first and the second thing that we did. But at the same time, you will see the similarities that will explain now why a predicate works that way. As in, like, we basically tell the system how to, for each item, respond that we get a boolean. We basically write our own behavior operator and put it inside here instead of using existing operators and then make a global decision based on it. And that's what the predicate is for. So what's the first thing we have to do? most of the magic happens in the operator tab, where we can press inside, and now we have a new search bar. So if you thought like, this search bar is big, I have bad news for you. There's another search bar, and that search bar is only for operators. What we want to do is we want to describe a behavior that the world entity importer can use on each item. But technically we have to do the same thing. We just have to describe the behavior instead of describing absolute things. What was the first thing that we did before? Well, we had an item and we wanted to get its NBT data, right? So we type item in NBT and it gives us two results here. These two results look a bit familiar because that's exactly the same results that we had earlier when we typed item NBT in the under search bar, but this time we are dealing with an operator. So as we already figured out, we do not need item NBT equals. What we want to do is let there be an item and give us an NBT. So I'm going to use this here for, and this is going to give us an operator where basically this variable now has instructions on how to turn an item into NBT. We do not actually turn an item into NBT. We are only giving him the instructions how it is done. This is the difference with an operator. Then we are in a very tricky situation. We now need the NBT extractor path, but this time we do not have a crystal that we can dynamically read or statically read. So how do we get this NBT extractor path? We use temporary variables, basically variables that we temporarily create and then throw away later so that we can get our path for now. We start the same way how we did in the first step. We're gonna make an item variable and make it static based on the item crystal here. So this is actually our item crystal. We're gonna need its NBT, which we also still have laying around. So here's our item, there's our NBT. We're gonna insert our item and there's our NBT. So far so good. We select size and now we can like get our extraction path again. But the issue is this is dependent on the item here again. This is exactly the issue that we had in the first step. But we don't want to do that anymore. We want to be able to apply that to every item to ever reach the world entity importer or world item importer. This is where this toggle comes in. If you have seen this toggle before, it says if you don't understand this, stick with reference mode. You're about to understand now. So basically what we have done so far is reference mode, whereas basically we are saying it should get us root astro sorcery crystal property size in relationship to the NBT data we inserted. So it will always expect that this NBT data is available and then get the size from it. Now we're giving him instructions on how to do it. And that's an operator. So now we are only saving the instruction if you see NBT data, see if there's astro sorcery, crystal properties, and then give me the size, whatever the size is. But we do no longer have this coupled to a specific NBT. So we can now take this out. We can throw this away. We don't need this anymore. We don't need that anymore. And this would still work, because this is only the instructions on how to get the size out of the NBT. And so as such, we're gonna call it that OP NBT size. So far, so good. Now we have two operators. We gave him one operator. We created an operator that tells him when there is an item, how to get NBT out of it. And now we have an operator where we tell him if there's NBT, how to get the size out of it. Because that's what we just did in the NBT extractor. Someone may realize, wait a moment, okay, we have item to NBT and we have NBT to size. can we assemble them to get the size out of an item? Exactly, that's what we're gonna do now. That's the pipe operator. Pipe accepts two operators and returns one operator. And what it does is, it takes the first operator's output and inserts it into the input of the second operator. So let's see, we don't need the temporary variables anymore, so we might as well use them for that. Pipe. We're gonna pipe the output of item NBT into the input of NBT size. Look at the naming convention, so that really makes sense at this point. And that gives us a new operator that turns item into size. I'm gonna, in that context, call it item NBT size, so that for the sake of the tutorial, it becomes clear how we basically take the item, turn it into NBT, and then turn that into size, and that all into a single operation now. Like, we basically took these two different sets of instructions, how to do something, and smashed them together into a single set of instructions that is based on these two sets of instructions, but in the way how we use it, basically, when we give him an item, it's gonna return us the size. Good. Now we have to get greater. Now the thing is, like, when we use this greater, we once again already assuming that we have finished values. We don't have finished values. We're giving him instructions on how to compare two numbers if they are greater or not. So we're gonna go back to the operator tab, and we are looking for greater. And there's relational greater than and relational greater than or equals, which is exactly what we've seen before here with greater than and greater than or equal. So, yeah, that's what we're gonna do. We wanna see if one number is greater than another, and that's gonna give us new operators. So, let's see. We don't need you anymore. And yeah, it's an operator, and it contains instructions on how to compare two numbers if they are if one number is greater than another. I hope that so far it is clear that what we're doing. We are not working with like finished fixed mathematical results. We're basically just creating different sets of instructions and assemble them in a way as we give him, basically telling him what to do when confronted with a new item. What I'm now gonna do is build in an intentional error, which is why I use greater. That is like so subtle that like someone would potentially not get the idea that it's an error. But I'm gonna build it in and then explain how to deal with it. So anyways, let's summarize again. We know how to turn an item into NBT. Instructions, we have instructions NBT to size. We have instructions for item NBT size. We now have instructions for how to check if one number is greater than another. We did not define any items or any numbers yet. So what we're now gonna do is like, okay, so obviously we're gonna get a number out of this, the size. We wanna see if the size is greater than something else. So the next logical conclusion would be that we pipe those. That's what I'm gonna do. I'm gonna pipe those two variables. Gonna use like u and be like, okay, so item NBT size is greater than something. That's something we didn't tell him yet. But basically we gave him no instructions on, for a given item, how to extract the NBT, then to extract the size, and that it's supposed to check if it's greater than something. What do we want to compare against? Well, a constant integer, 800, right? So we're gonna do that again. And see like, okay, let's lose this, int 800. There's our int 800. And then we gotta tell them to apply this 800 to eliminate one of the inputs. How are we doing that? Is by using apply. Apply is a special function that in the instruction says apply for a given operator, a given value. Basically, for an operator, we remove one of the inputs for a value that is predetermined and not something that dynamically changes. And in that case, the int 800 is a constant. It's always gonna be, we're always gonna check if we're bigger than 800. So that's what we're gonna use. We're gonna apply, we need an operator, which we're gonna use our operator item NBT size greater for and our int 800. And now we wanna save that operator as our predicate. And that's it. Okay, so what did we do? Let's go over this again. We gave him instructions. If there's an item, how to get NBT out of this. Then we gave him instructions if there's NBT, how to get the size out of this. Then we smash them together so that when we give him an item, he knows how to get the size out of this. Then we told him that he's supposed to see if there's one number that is greater than another. Then we told him the first number is size. So basically that we, when we give him an item, how to check if it's greater than another number. Then we told him that the other number is 800. That's our predicate. Right? We're gonna insert all of this. We're gonna run into an issue. Gonna insert this into the predicate. The operator, piped operator, received an input with type operator at position 0 while the type in item was expecting for Korean. If you try to look up this error, you're not gonna find a lot. You honestly not even gonna find a lot about the word Korean. What happened here? Let's take a look at the Haskell code, because it doesn't even seem too obvious about what happened here. Like it's not trivial on what went wrong here, which is why I included this example. So what we did right is this. We also did this right. We also did this right. This is also correct. Where the problem starts is here. We have two inputs, number, number, and we return a boolean. We told them, okay, pipe into the first number, so that we think like, okay, we have our size. It's gonna check if size is greater than another number, and then we return a boolean. And then we set the second number with the integer 800, and then basically just applied it. And so the idea is like we have basically size greater than the constant, and then it gives us back a boolean. That doesn't work, however, because what is essentially going wrong is like, because there's two numbers we can pipe into, it doesn't really quite know where to pipe into. This is essentially my explanation to what's going on here. If you're doing a pipe and you have one output, you also only want to have one input. If you have two outputs, this happens. And maybe you realize now why I used greater than and not equals for this example. If I would have used equals, what we can do is we just apply the constant first and then repipe our size into. So we basically see if 800 is equals the size. And that works because if we use apply, we consume the first input. It is fixed, so it's gone. So there's only one input remaining. So when we are piping, there's one output and one input. So equals in this situation is a lot easier to do than greater than, because we have two inputs to deal with. But at the same time, we cannot do the constant here first, because if we do the constant first, what we would check for if 800 is bigger than the size. We basically invert the logic, and it doesn't work anymore. So for this to even function, we need to have the ability to insert a value into the second input first before we are piping. And this is where flip comes in. There is actually an operator for exactly this problem that is called flip. So let's look at our variables. So this is completely correct. This is also correct. Where our problem happened is when we started to pipe while there was 2 inputs. Let's take this out and let's redo this. So what does flip do? The flip operator flips the 2 inputs around, and that's it. So you're probably thinking that doesn't make any sense, because if we flip them around, we have exactly the same issue as if we are like writing the constant first, like 800 bigger than size. But this flip does not actually change the logic, as in like it still is aware that the first thing that we input is supposed to go at the second location of the greater than. So this is very easily to get confused. And what you have to get right is that you already have to use this on the greater operator before you even insert any numbers, because otherwise you can't flip when you already apply, because flipping assumes that there's 2 values. If you first apply the constant and then flip, there's only 1 input, so it doesn't know what to flip it with. So we take our OP greater, then be like, yeah, let's throw it in here. So flip greater, and what we've essentially done is now we have told them the next thing we insert is supposed to go at the second location of the greater operator. So this is where our constant comes in. So we make a new constant. Let me see, have I messed something up, or? Nope. Okay, that's still okay. That's still fine. Let's just use this one then for int size. Oh yeah, the number is 800. The name goes in here. I was confused for a short moment, but we are fine now. We have got the int 800, and then we go apply this. So we have our flipped operator. We apply the int. Let's save that as op greater 800, because that's essentially what it do. We see if something is greater than 800, and now there's 1 input remaining, and that 1 input is the first input. So now we can do the same thing that we did before, where we are piping the OP item NBT size into the greater 800. And that becomes our predicate. Okay, so let's see. Let me remove. Oh boy. Remove all of this. So let's go over this very slowly again. We gave him instructions on if there's an item, how to extract the NBT. We again gave him instructions on how to get the size out of that out of NBT. Then we told him to connect the two on the NBT part, as in like when you give him an item that he returns the size. Then we told him that there let be a greater operator where the first number needs to be bigger than the second number. Then we flipped that so that the next input that we give goes at the second location of that greater operator. We put the constant here, so that way what happens is that we get an operator where it says something must be greater than 800, which is what we want to go. Then at the last step, we told him, okay, so I want to take my size with a pipe and I want to see if it's greater than 800. And this is but now goes into the predicate. Now, if I'm throwing in a pickaxe, it's not going to get picked up because its size is not greater than 800. When I throw in a small crystal, that's also not going to get picked up because its size is not greater than 800. And if I now throw in a big crystal, it's getting picked up despite the pool already being polluted with other things. So even when I'm in like in this situation now where like, oh no, I suck at building here. I suck at building here. I have broke the ceiling and there's a marble in here. And a new crystal like grows to the right size. It gets picked up. And it doesn't despawn because of the cobblestone polluting something. I hope that this explains what the deal with predicates is, as in like we no longer need the reader and we have made something that checks for literally everything that we throw inside this pool if it's greater or not. And this can be applied to obviously not just items. You can do this with blocks. You can do this with tile entities. You can do this with different NBT tags. You can import based on it. You can export based on it. At the end, this is a massive sandbox. You can do with it whatever you want. But I hope that this explains not only how predicates are done, but why they are done this way. Be told that this is not the only solution to this problem. There is, because of how powerful this tool is, there's other ways how you can approach this. To give one more example that I can give to save one variable card, as one may have realized, the entire problem that we have with having to flip the operator is based on the problem that we have to insert the pipe first and then the constant. So we have to flip around that we first insert the constant and then the pipe. We can also solve that differently when we not use greater than. Because what else can we do? What if we use less than? When we use relational less than, let there be an OP less. Gonna make this a little bit quicker. Now the video is already way too long. When there's an OP less, and there's an integer 800, I'm just gonna reuse it this time now. Then, well, we check if 800 is less than the size of the crystal, which is kind of what we want to do. It's just we have turned around the operator now, so the constant goes in the first place. If we want to see if the crystal is bigger than 800, we want to see if 800 is smaller than the crystal. So when we have the lesser operator on 800, we can now immediately apply the constant to it. I'm gonna use this card here. So 800 is less than something. And now all we got to do for the final step is to pipe item size into the remaining input of OP 800 less, which gives us our predicate. So what we basically just did, let me get rid of all of these, we won't need them anymore for this video. So the way how we get the size didn't change, because that is written in stone. What we have changed is, instead of using greater than operator, we have now used less than operator. Because of that, we can now put the constant on the first slot and pipe into the second slot, which means that we do not need to use flip, and it saved us one variable card. Now those cards are not really expensive, but it shows how just changing an operator can decrease the complexity of the system, because this system just works like the previous one. If I throw this one in, it's not going to get sucked in. If I throw this one in, it's not going to get sucked in. If I throw this one in, it gets sucked in. I'm going to show the final code now for this example with less than. Here the flip variant. I should probably let's use nvim. But it's basically the same ideas, like we just use lesser. Oh wait, no, it's not the flip example. I wanted to show the less example. Well, like the way how we get the size didn't change. The way how we check if in which relationship the size to the constant is did change, and that way we saved one variable, and the entire system is now solved with a total of 7. If you happen to be in the situation that you watch this video because you were looking for the Astral Sorcery solution, I guess you can copy it. If not, I hope that I not ended up wasting too much of your precious lifetime with a 1 hour and 20-minute video, and that this is actually like a comprehensive explanation from like very primitive problem solving all the way up to why do we use predicates and how do we make them, so that you can assemble your own machines at the end. Even if I, at the end, had to realize that this didn't really help me because, yeah, I have now the ability to detect if a crystal has the right size and the right purity. I used in creative mode crystal here, where cutting isn't done yet. Where cutting is already done. But if I were to have to do cutting, I would have to use a grindstone. And the thing is, even with integrated dynamics or other means like the mechanical user of X-ray utilities, I think, X-ray utilities 2, I had to learn the hard way that the grindstone cannot be automated. So, to some degree, I wanted to add this to the end as in like, integrated dynamics is very powerful, and I like to use it, especially when I have to do very cursed things with NBT. Like, in this particular case, it allows me to do almost perfect crystals now. I have to do the cutting by hand. Another example, which is how I got to the mod the first time, was apotheosis. You can make a very comprehensive mob farm filter with integrated dynamics and filter for apotheosis items after rarity and such, or like after other values. And if you plan to do that, I wish you good luck. With the information that I gave you here, you should be able to do that now. But I also wanted to add in that, like, sometimes even the biggest tools cannot automate everything. So if anything, I do suggest that you join the communities that belong to this mod and the mods that you try to automate, but also that you consider making like an creative playground where you're testing out things before you start integrating them in your base, especially since integrated dynamics has that issue where like every time you're making a new variable or defining a new part, it defines a new ID. Like this display panel has the ID 4 now, this 5, this 6. Integrated dynamics is like not this mod where you just want to build random shit. You're not going to get really far with how many things you can do in here. It's this type of mod where you want to have an idea, not wants, where you want to go with this. And you want to be in this position of not only gaining knowledge, but also sharing it with others to save your own lifetime, but also to save the lifetime of others. It's this contract of like, I have now dedicated 1.5 hours of my life to tell my future self, but also you, what there is to know about this mod or like how you can use it. And now it's your job to go outside and help others with that knowledge. As in that we built on the shoulder of giants, and prevent people from having to figure out the same things over and over again when there's others that have already figured it out for them, so that we can proceed solving solutions and doing advancements that others have not done for us before. And with that, I'm ending this video. If there's any questions, just feel free to go into the comment section. I will try to answer them, but be advised that there is certain limitations to how much I know about integrated dynamics. Granted, with everything that I've told in this video, you should be able to more or less reasonably draw conclusions on how to use everything else in here. But there may be exceptions, and in case that I don't know how to proceed, or if you're in a hurry, you should definitely go on the Discord server. There's people on the Discord servers on the Discord server for this mod, and also for like your mod pack of choice, that been dedicating several years of their life to figuring out how to automate things, how to use integrated dynamics, that can see a problem with your system within seconds where I would probably spend hours. So I suggest that you go outside and meet with other people and have a great time. And yeah, that's basically it. That's all I have to say. Now, yeah, that was my emotional deep speak. They do with